Hey folks, Mr. Dell here. We are looking at a scatter plot and trying to do some interpretation of the data and the line of best fit and all the things involved. So this is a problem coming from CPM's Math 1, Integrated Math 1 curriculum, and this is section 2.2.3, number 2-73. So it says, a consumer magazine collected the following data for fuel efficiency of cars, so the fuel efficiency in miles per gallon, compared to the weight in thousands of pounds. So those are the two things we're comparing. So we have our miles per gallon, our fuel efficiency as the y-axis, right, as our y-axis, and then the pounds here, the weight, thousands of pounds, is the x-axis, right? That's my x-axis. So it says E equals 49 minus 8.4 W, where W is the weight of pounds and E is the efficiency. So really, we call this X, that is usually our X-axis, but it's going to be our W-axis in this case. And then this is our Y-axis, but this is going to be our E-axis, right? So normally it's our X and Y, but I'll keep those up there. That's my Y, that's my X, but our variables this time are W and E. So it asks some questions here. So first question it says is, what does the negative 8.4 in the equation represent? Okay, so what I'm looking at, this equation, this 49 minus 8.4 W, E equals, that's that line of best fit. That's what I'm dealing with, line of best fit. That's the line that we see on the graph. That's this line right here, that solid line that goes through the data. That's the equation of that line. So if we think about an equation of a line, right? Review of equation of a line, you write it over here, y equals mx plus b. M is always the rate. It's the growth rate, or if it's the rate it's decreasing. W is, or the b term is always the initial value, or the y-intercept, right? The initial value. So in my equation here, this E equals 49 minus 8.4 W, we really, if I want to write it in y equals mx plus b form, it would be E equals negative 8.4 W. So we put the mx term first. That's the negative 8.4 W plus 49. So that's in more of that form there. And again, if we were looking at this being y's and x's, it would just be take the W away, and it'd be y equals, take the E away, make it a y, negative 8.4x plus 49, right? So that form is the slope-intercept form, or the rate initial value form, but instead using E's and W's, right? So I'll put it back to what it was. It's an E and a W. All right, so let's answer this question again. What does the negative 8.4 rate? Well, that's our rate. Negative 8.4 is the rate. So that's our rate, and it's our slope, our rate or slope, okay, of the line of best fit. Or regression line is another word that we use, and I'll write that out. Technically, it's called a regression line, right? That's the statistical term, but line of best fit is also known as. So, but what are the units? So the units are miles per gallon per 1,000 pounds. So we would say negative 8.4 miles per gallon per 1,000 pounds. That's really what that is. So it's decreasing, so that's the negative, decreasing 8.4 miles per gallon per 1,000 pounds. So we can even write that in here. So, it actually is the next question. I'm getting ahead of myself here. What are the units on this number? I just answered that. The units are miles per gallon per 1,000 pounds. That's the units, okay? So I'm going to erase that up here, because I want to say this negative 8.4, what that means, it's decreasing 8.4. each time. It's decreasing 8.4 miles per gallon per 1,000 pounds. And okay, so what does the 49 represent? So let's keep going. What does the 49? The 49 is this part of the equation, which is my initial value. It's the initial value, also known as the Y-intercept. And so the units for that would be where this line would have began, right? Where the rate would start. And keep in mind this isn't 0, 0, so it's not a perfect graph. I can't take this line and continue up. It's not necessarily hitting it there, right? So there's a gap in this data. So we have to trust our equation. And so the units in this case would be that would be 49 miles per gallon. Okay. And that would be 49 miles per gallon at 0 pounds, which doesn't make sense because 0 pounds, you wouldn't have a car weighing 0 pounds. But that would be that's what that would represent. Describing the association between fuel efficiency and weight. So the association, remember, is how does the data progress? So first of all, is this a strong correlation or a weak correlation? If I look at the kind of some outliers here, the data is not really a tight set of data. Now, if all it was just this set of data, that would be different. Then that would be a little bit more of a stronger correlation. So I wouldn't say it's a weak correlation. I'd say a moderate correlation. So it's a moderate, not weak, not strong, moderate. Uh, oh, there we go. I lost my work there. One more time. So I'd say it's a moderate, and not only moderate. The other ways we can say would be we know it's decreasing. So moderate, decreasing, linear, because linear meaning the describing the pattern. The pattern is more linear than it is anything else. So just decreasing, moderate, decreasing, linear association. Okay. Last question. Cheetah Motors has come out with a super lightweight sports utility vehicle, an SUV, that weighs 2,800 pounds, 2,800 pounds. What does the model predict the fuel efficiency to be? So question is, where on my model, where on my linear regression would I find 2,800 pounds or 2,800 pounds? So if I look at my graph, remember the pounds are the x-axis here. So 2,800 would be somewhere right in here. So if I bring that up, because that's 2,500, that's 3,000, remember, because it's in thousands. If I go up to my line, I'd say somewhere right there. And where is that as fuel efficiency? Maybe we could say that would be 25 miles per gallon. So approximately 25 miles per gallon. All right, there we have it.